Hi everyone. Today we're going to look at operations with rational expressions. It's a little bit of a longer lesson and there's quite a lot to cover, but feel free at any point to pause the video, rewind, go back over something. We're going to start with just the basic principle that how we work with rational expressions is the same rules for how we work with fractions. So when we're simplifying, the idea with fractions is that we factor the numerator and the denominator, whether we do that explicitly or we're just sort of doing it in our heads, and we're dividing out common factors in the numerator and the denominator. So to illustrate that with an actual numeric fraction like 18 over 63, I'm going to write out steps that I probably wouldn't bother writing out with a numerical fraction, but for example, I see that 18 and I'm going to factor it into its full prime factorization. So that's 2 times 3 times 3. And 63 is 3 times 3 times 7. I don't actually have to do the full factorization here. I would be completely okay to just write 2 times 9 and 9 times 7, because the 9 is, of course, the common factor. But if I have it completely factored into prime factors, that's a little closer to what I would normally do with an actual rational expression. So I can then cancel out the common factors. Now, I'm using the common wording of cancel out, but an important thing to keep in mind, and this will be important as we go through this lesson, canceling is not a mathematical operation. Canceling is division. So what I'm doing when I cancel common factors is I'm dividing by the common factor of 3, for example, in the numerator and the denominator. And because I'm dividing by the same thing in the numerator and the denominator, it's essentially as if I'm dividing by 3 over 3. So I'm dividing by 1. That is why I'm allowed to do that, because division by 1 does not change the value of the fraction. So in the end, I get an equivalent fraction, in this case 2/7. That is the most simple form of this fraction because it has no more common factors. So that's the basic idea. The only thing that changes when we have a rational expression is that we now have the potential for non-permissible values. We don't really have an issue with non-permissible values in a numerical fraction because non-permissible values come from division by 0. 18 over 63 is 18 divided by 63. 63 is not 0, so no problem there. But in this next example, where I have a variable in the denominator, I actually do have the potential for division by 0, so I have to keep that in mind. And I want to deal with it right up front. I want to deal with the fact that this denominator cannot be 0. So 63x to the power of 5 cannot be 0. We can divide both sides by 63. We can take the fifth root. Ultimately, what we end up with is x cannot be 0. So that's the non-permissible value here. That's also going to be important to keep in mind as we do our simplification. But remember the process. We factor. We look for common factors. So in this case, my numerator is binomial. So to factor it, while I have a common factor, and I'm actually trying to pull out the greatest common factor between 18x to the power of 4 and 45x cubed, the greatest common factor here is 9x cubed. And when I divide 18x to the power of 4 by 9x cubed, I get 2x. Minus 45x cubed divided by 9x cubed is minus 5. In the denominator, I'm going to sort of semi-factor it. I could factor it fully into prime factors like I did in the previous example, but I'm just going to go with the 9x cubed because that is the factor that I have up top. So 9x cubed, and what is left is 7x squared. Now, remember when I said before that canceling isn't a mathematical operation. So I'm not really canceling the 9x cubed. I'm dividing by 9x cubed. So I'm dividing by 9x cubed over 9x cubed, which is just dividing by 1. But here it's important to note that restricted value is still in play because I can't divide by 9x cubed if x equals 0. So I have that restricted value that x cannot equal 0. So what I end up with is an equivalent fraction of 2x minus 5 over 7x squared. These two fractions are equivalent, but both of them in this case have the restriction that x cannot equal 0. So it's a simplified fraction that was equivalent to my original fraction. So these two right here are equivalent fractions. And in this case, they both do have the same restriction. That won't always be the case. In fact, we'll see in this next example that it isn't always the case. So one more where we simplify before we move on to multiplying and dividing. So we have x squared minus 25 over x squared plus 3x minus 10. Now, there's a temptation with these to say, oh, I can cancel x squared, or I can divide 25 and 10 both by 5. Nope, can't do that. You can't cancel pieces of a binomial or a trinomial. If there's an addition or subtraction, that connects those two pieces, and you can't cancel part unless you can cancel all. We can cancel factors because we are allowed to divide the numerator and the denominator by the same thing, because we can divide by 1. We can't add or subtract things to the numerator and the denominator because that's not the same as adding or subtracting 1. And even if it were, adding or subtracting 1 is not allowed. That changes the value. So I have the restriction that I can only do multiplications and divisions. So in this case, that means I factor so that it's expressed as a product so that I can see what I can divide out. So the factors of the numerator are x plus 5, x minus 5. The factors of the denominator, x plus 5, x minus 2. Now, as we go through this lesson, you'll see that factoring comes up a lot. So being able to factor quickly and efficiently is really important. If you're not quite yet at that stage, then you probably need to practice some factoring to make sure that you're able to do it as efficiently as possible. Now that it's expressed as factors in the numerator and the denominator, I can see that I do have a common factor of x plus 5. So I can divide that factor out. But hold on, I can only divide that factor out if x doesn't equal negative 5. So the fact that I'm canceling out this factor, dividing out that factor, means that that restriction needs to stay in place. Now, my original fraction has two restrictions, x can't equal negative 5 and x can't equal 2. The fact that I'm canceling the x plus 5 does not cancel the restriction. So in other words, I end up with an equivalent fraction, x minus 5 over x minus 2, that has two restrictions. X cannot equal negative 5 and x cannot equal 2. In spite of the fact that when I look at this fraction, it only looks like x can't equal 2. There's actually no reason to have negative 5 be a restriction if I'm only looking at this final fraction. In this final fraction, I can plug in negative 5 and I don't have any problem. I get negative 10 over negative 7 or 10 over 7. That's an actual answer. There's no division by 0 in that. But because I'm wanting this fraction to still be equivalent to the original fraction, I have to keep the same restriction I had in the original fraction. So these two fractions are equivalent, but their restrictions aren't exactly the same. So I have to keep the restriction from the original fraction. All right, moving on to multiplication and division. Multiplication to start. Remember that, essentially for fractions, multiplication is the same as simplification. So we multiply across the numerators. So this would be 8 times 25 and 15 times 16. But I'm actually not going to bother doing that multiplication because our next step would be to simplify the fraction. So simplifying involves factoring, and factoring is the opposite of multiplication. So why would I multiply those two numbers together just to have to divide them back up again? I'm not going to. So I'm just going to write 8 times 25, and then I'm going to factor it even further. I'm not going to fully factor it. I'm going to look at what I have top and bottom. I'm going to say, okay, well, this is 8 times 5 times 5. The reason I didn't break up the 8 is because I can see in the denominator that I have 16. So I'm just going to write this as 3 times 5 times 8 times 2. So I'm basically just dividing it up enough where I can see the common factors so that I can divide them out. With numbers, I could possibly just skip straight to this step, 5/6. So I'm showing more steps here than I would necessarily for an actual numerical multiplication, just to illustrate what happens with rational function, or rational expressions. All right, so that's the basic idea. It's the same basic idea when I start introducing rational expressions. So 9 times x, I'm actually going to write the x squared as x times x. 15 is 3 times 5. And in the denominator, I have 5 times 2 times 9 times x. So I'm going to write it out that way. Well, this kind of looks like a subtraction. It's not a subtraction. It's a multiplication. All right. So I've just divided it up enough that I can see the common factors. I didn't bother factoring the 9 into 3 times 3, although I certainly could. And that gives me the 9s are common. One of the x's is common. 5 is common. So in the numerator, what's left? 3x. And in the denominator, what's left? 2. Now notice that this final expression actually isn't a rational expression anymore, and it doesn't have any non-permissible values because the denominator is just 2. However, I do have to keep the restriction that x cannot equal 0 because I did have an x in the denominator to start off with. So x can't equal 0. Or you can think of it as I canceled out an x, but I can't cancel an x if I can't divide by x. And I can't divide by x if x is 0. So that is the final answer here. Let's put a box around that one just to complete it. All right, so if it gets a little more complicated, as this one does, it's still the same process. You factor, you cancel common factors, you write what's left, you make sure you're including all your restrictions. It might be a good idea here to pause the video for a moment and see if you can try this next one on your own before continuing the video and seeing the solution. But assuming that you've now paused that and tried it and come back, here's what I get. So factoring 2x plus 8, I get 2 times x plus 4. Factoring x squared plus 3x plus 2, I get x plus 2, x plus 1. In the denominator, x squared minus 3x minus 10 is x minus 5, x plus 2. 2x squared minus 32, now I'm going to kind of partially factor that over here because I have a common factor, which is 2 times x squared minus 16, but x squared minus 16 factors further to x plus 4, x minus 4. So I fully factor. It's at this stage that it's a good idea to consider your restrictions. So once it's factored, but before you cancel anything, because I have x can't equal negative 5, x can't equal negative 2, and x can't equal positive or negative 4. So those are my restrictions. They're going to still be my restrictions when I cancel stuff. So I can cancel the x plus 4. Oh, I can cancel the 2. I can cancel x plus 2. And what we're left with then is a numerator of just x plus 1. And in the denominator, x minus 5, x minus 4. There's no reason to distribute that denominator back out. Sometimes we will have to redistribute the numerator. We'll see some examples like that in a minute. But you're pretty much never, ever, ever going to have to redistribute the denominator. Just leave it in factored form. And I have my restrictions. X can't equal negative 5. X can't equal, x can't equal negative 2. X can't equal positive or negative 4. You don't technically have to repeat the x cannot equal. You could write it as x cannot equal negative 5, negative 2, plus minus 4. The reason I always repeat the x equals has to do with the fact that I also teach in French. And in French, I can't just put commas between numbers because that's a decimal place, so I always just repeat the x. But if you're wanting to save yourself a couple of seconds on every question, you don't have to rewrite the x. All right. Oops. I said here that x does equal negative 2. It does not equal negative 2. Okay, let's move on. One more multiplication example, and then I think we have some division. Oh, no, 2 more multiplication, and then we have some division. All right, so again, I would pause the video if I were you. Give these a try. See if you can get the correct answers before resuming the video and getting the answers I get. All right, so we've got 2x, x plus 3, x minus 3 in the numerator. In the denominator, I've got 3 times x minus 3. I've got 2x times 2x minus 1. All right. So common factors, well, the whole 2x goes. You can think of the 2x as one thing, or you can think of it as a 2 and an x. Either way, it's all going to cancel. And x minus 3 cancels. Remember, though, that I want my restricted values, my non-permissible values, to come from this stage before I cancel anything out. So I have 3 non-permissible values here. And my ultimate simplified fraction is x plus 3 over 3 times 2x minus 1. It's helpful. Sometimes I don't do this all the time, but sometimes I will. I'll put that x plus 3 in brackets, even though it doesn't technically have to be, just to remind myself that that is a single factor. X plus 3 is one thing. I can't cancel any part of it unless I can cancel the whole thing. So in other words, I can't cancel that 3 with the 3 in the denominator because it is x plus 3. Those are connected. And my non-permissible values, x does not equal 3, x does not equal 0, x does not equal 1/2. Even though the 1/2 is the only non-permissible value that is really obvious in this simplified fraction, the other two are still restricted values in order to make sure that this fraction is equivalent to the original. And finally, factoring this one, we get x minus 5 times x minus 5 times 3x times x minus 1. And in the denominator, we have x minus 5 times x minus 1 times x plus 5 times x plus 2. So in this case, our non-permissible values, x does not equal 5, x does not equal 1, x does not equal -5, and x does not equal -2. One of the x minus 5s in the numerator will cancel. The x minus 1 will cancel. So what we're left with here, 3x times x minus 5 over x plus 5 times x plus 2. And my restricted values, x does not equal positive or -5, x does not equal 1, x does not equal -2. All right, that's multiplication. It's essentially just simplification, but where we first have to combine two fractions. Division is exactly like multiplication, except that we first have to turn it into a multiplication, and then there's a little tricky thing with the restricted values, which we'll get to in a moment. But my first step here is that I turn this into a multiplication by multiplying by the reciprocal of the second fraction. So I'm going to write this step out. In actual practice, I would normally do this step while also factoring. I would combine those two steps together. But just to be very clear here in the notes, my first thing is to turn this into a multiplication. And from here, it's exactly like the questions we've previously done. So I'm going to factor the factors of this numerator. X, let's see, I've got 6 and 1. Yeah, so I've got 2x minus 1 and x minus 6. The second numerator has a common factor of 3 times x minus 7. X squared minus 49 is x plus 7, x minus 7. And 4x squared minus 4x plus 1 is 2x minus 1 times 2x minus 1. All right, at this stage, I'm going to contemplate my non-permissible values. So x can't equal plus or minus 7, and x can't equal 1/2. Oops. Yes, positive 1/2, but I don't have to write the plus sign. I also have this factor to consider, because that factor was originally in the denominator. So it also gives me a non-permissible value. In this case, it doesn't give me a new non-permissible value because there was already an x minus 7 in the denominator of the first fraction. But that's the difference in non-permissible values for divisions. Anything that was ever in a denominator at any point has to be considered for restrictions. So in this case, I would not get any new ones, but I still should look at it. Now I can cancel common factors. And we end up with, as a simplified fraction, 3 times x minus 6 over x plus 7 times 2x minus 1, with the restrictions that x does not equal positive or -7 or 1/2. So division and multiplication, basically just like simplification. Division, you have that extra step of turning it into multiplication, and you have to be careful with your non-permissible values that you are looking at anything that has ever been in a denominator at any point in your entire process. All right, like with fractions, addition and subtraction is a more complicated operation. I can't just add, I need a common denominator. And we are going to, for the most part, be looking for the lowest common denominator. The reason we'll look for the lowest is because it makes simplifying easier at the end. That may not be a huge deal with numerical fractions, but it is a huge deal with rational fractions, because the higher the degree is, the harder it is to factor. So if you don't find the lowest common denominator, you're going to end up with fractions that have way too high a degree, and you may or may not be able to factor those. So we need to be really careful here. So the lowest common denominator of 4 and 6 is the least common multiple. So the least common multiple of 4 and 6 is 12 in this case. So I look at this and I have to write equivalent fractions with 12 as the denominator. So that in this case would be 9/12 plus 10/12. So we end up with 19/12 as our answer. Because I've used the lowest common denominator, it reduces the likelihood that I'm going to have to simplify, but it doesn't eliminate it completely. So I should check my final fraction to make sure I can't simplify any further. And I can't. 19 is a prime number, so this one is done. So once we start doing this with algebraic fractions, the same principle exists. So I'm going to look for my lowest common denominator. In this case, they both already have an x, so that's going to be part of my denominator. But 10x is the lowest common denominator, because all I have to do in that instance is multiply the numerator and denominator of the first fraction by 2, and then I will have 10x as the denominator. So I end up with 6 over 10x minus 3 over 10x, which is 3 over 10x. I do have a non-permissible value. X cannot equal 0. So that's the basic idea here. Obviously it gets more complicated once I have numerators and denominators that are not just monomial. So let's look at this. There's a tendency here to look at this and say, oh, I just have to add 2x onto the first fraction. But remember, we can't add things into the numerator and the denominator. The only things we're allowed to do are multiply and divide. So like with our previous multiplication and division, our first stage here, in order to determine the least common denominator, is to factor. We have to factor anyway to find the restricted values. So let's start by looking at the factors of these denominators. X squared plus 2x is x times x plus 2. I'm actually going to write the x squared as x times x. Now, if I look at this, they both already have an x in common. So essentially what I need to decide is what factor is each one missing that's going to allow me to come up with the lowest common denominator. So my lowest common denominator, if you remember finding least common multiples, it was include all the factors but don't repeat any of the ones that are shared. So the x that is common is going to be part of my lowest common denominator. So I'm going to highlight that in yellow to indicate that's the x that they already shared. Now I have an extra x, and I have an x plus 2. So that is my lowest common denominator, which means for each fraction, I have to multiply by the factor that's missing. So in the second fraction, I multiply by the extra x over x. In the first fraction, I'm multiplying by x plus 2 over x plus 2, which means that my new fractions are x plus 2 over x squared times x plus 2 plus x over x squared times x plus 2. Now I have a common denominator. I'm definitely not going to just go canceling stuff because there are things that cancel in each of these fractions, but that's actually the point. I put those things there on purpose so that I would have a common denominator. Now I can combine these and I get 2x plus 2 over x squared times x plus 2. I'm going to factor that numerator. I mean, it's pretty obvious these ones aren't going to simplify, but I'm going to factor the numerator because I want to make sure that I can't simplify this fraction any further. So I get 2 times x plus 1 over x squared times x plus 2. Now I also want to think about my non-permissible values. So non-permissible values come from the original denominators. Here it's also the end denominator. X can't equal 0 and x can't equal negative 2. So that's our basic idea. Find the lowest common denominator by factoring. Then you can combine numerators. Then factor if possible to see if you can simplify any further. All right, so I'm going to put these two questions up. Maybe try pausing the video here and giving these questions a try before resuming the video. Assuming that you've tried them, my first stage in figuring out the lowest common denominator is going to be to factor. So I have 5 times x plus 1, 2 times x plus 1. Now, just a comment here, you could find a common denominator just by multiplying 5x plus 5 times 2x plus 2. But you'll be using you'll end up with quadratics, it'll have to simplify, and sometimes you would end up with cubes or even 3/4 that you don't know how to factor. So you wouldn't end up with the simplest fraction at the end, and you wouldn't really know how to simplify it even. But here, my lowest common denominator has to have the 5, it has to have the 2, and it has to have the x plus 1, which is already common, so I don't have to repeat it. That means that the first fraction is missing the 2, so I need to multiply by 2 over 2. And the second fraction is missing the 5, so I multiply by 5 over 5. This means I now have 8 over 10 times x plus 1 minus 15 over 10 times x plus 1. 8 minus 15 is negative 7 over 10 times x plus 1. Nothing cancels there, so this is simplified, and x cannot equal negative 1. There's the final answer. In this next example, when we factor, well, this first one already is factored. The second one becomes x minus 3, x plus 1. So we have an x plus 1 that's common, which means that my lowest common denominator is just x minus 3 times x plus 1. So I don't have to multiply by anything in that second fraction. It already has the right denominator. But in the first fraction, I'm multiplying by x minus 3 over x minus 3. We do have to remember to distribute. So I have to distribute that 2 to the whole x minus 3. And, tricky thing in this question, I have to distribute this minus sign to the x minus 1. So in other words, if I write these like this, so I'm going to already combine it to a single denominator. I know my common denominator is x minus 3 times x plus 1. So what I have is 2 times x minus 3 minus, and I'm going to bracket the x minus 1. So essentially thinking of that as one thing, because the minus is going to have to distribute to that. So in other words, 2x minus 6 minus x plus 1 over x minus 3x plus 1, which becomes x minus 5 over x minus 3 x plus 1. That x minus 5 is all one factor, so it can't cancel with anything. Non-permissible values are negative 1 and 3. So if you tried this question and you forgot to distribute that minus, that's the tricky thing about this question. So you do have to be really careful with subtractions. All right, 2 more, I believe. Yep, 2 more. Again, feel free to pause the video, give them a shot, practice before resuming. All right, so to factor these, I'm going to factor numerator and denominator because it's worth my while if I can simplify these fractions individually first. So I have y minus 2 times y minus 1 and y plus 6 times y plus 4. In the denominators, I've got y minus 4, y minus 1, and y plus 2, y plus 6. All right, so this actually gets a lot easier right off the bat, before I even worry about a common denominator. So if I were to not simplify these individually, my common denominator would be y minus 4, y minus 1, y plus 2, y plus 6. Each fraction would have to get multiplied by 2, which would mean a quadratic times a quadratic, degree 4. That gets complicated pretty quickly. But because I can simplify each individual fraction, I don't need to worry about the y plus 6 and the y minus 1. They are still going to be non-permissible values, but my lowest common denominator in this case is just going to be y minus 4 times y plus 2, which means that in the first fraction, all I have to multiply by is the y plus 2 over y plus 2. And in the second fraction, I have to multiply by y minus 4 and y minus 4. I did have to be very careful there. With multiplication and division, I could cancel common factors regardless of which fraction they came from. With addition and subtraction, I'm only looking at a single fraction to see if I can simplify first. Now what this gives me, well, I have y plus 2 times y minus 2 in the first fraction. Oops. So I've got, actually, you know what, what is happening? Okay, random resizing. Here we go. So I've got y plus 2 times y minus 2. This is a subtraction question, so it's going to be minus y plus 4 times y minus 4 all over y minus 4 times y plus 2. Again, it's tempting to want to cancel common factors now. I can't do that because I still have the subtraction. When I have a subtraction or an addition, it's tying everything together, so I can't simplify it yet. Y plus 2 times y minus 2 is y squared minus 4. Y plus 4 times y minus 4 is y squared minus 16. I'm still keeping them in brackets because I have a subtraction. Notice that I do have to distribute out the numerator. I have to distribute out the numerator so that I can simplify it, but at no point do I bother distributing the denominator. So this becomes y squared minus 4 minus y squared plus 16 over y minus 4 times y plus 2. The y squareds are nicely going to cancel, and minus 4 plus 16 is just 12. So I end up with, as a final answer, 12 over y minus 4 times y plus 2. Now my restricted values, I've got the y can't equal 4 and y can't equal negative 2 that come from the common denominator. But I also have that y can't equal 1 and y can't equal negative 6. Those are the two factors that I canceled out in the very first step, but I still have to include them for non-permissible values. And finally, again, we start by factoring. So I've got a minus 3 times a minus 4. The numerator can't be factored. And in this one, I've got 3 minus a, 3 plus a. Now it looks at first glance like there are no common factors between these two denominators, but there is. So I can switch the order of 3 plus a to a plus 3, no problem. So I'm going to do that just because it's a more common way of writing these things with the variable first. 3 minus a, though, is not the same thing as a minus 3, but it is the opposite of a minus 3. In other words, I can write it that way. I want to do that because then I can use a smaller lowest common denominator. My lowest common denominator is therefore just a minus 3 times a minus 4 times a plus 3. I don't need to worry about the minus. I'm basically just going to change that addition into a subtraction. So in the first fraction, what's missing is the a plus 3. So a plus 3 over a plus 3. Remembering that this numerator is binomial, so I'm going to have to use distribution. And in the second fraction, a minus 4 over a minus 4. This then gives me, all right, so I've got a plus 3 times 2a plus 7, minus now, because I changed that into a subtraction, 2a times a minus 4, all over a minus 3, a minus 4, a plus 3. Distributing the numerator, I get 2a squared plus 7a plus 6a plus 21 minus 2a squared plus 8a all over a minus 3, a minus 4, a plus 3. The 2a squareds in the numerator are going to cancel, which is nice because then it means I don't have a quadratic. 7a plus 6a plus 8a is 21a. So I've got 21a plus 21 over a minus 3, a minus 4, a plus 3. I don't technically have to factor this numerator. I'm going to, but I can already see that it's not going to simplify, but I'm going to factor it just because I want to double check and make sure that this fraction can now not be simplified any further. Sometimes it can at the end. So I get this. And with the restrictions, a cannot equal positive or negative 3, or a cannot equal 4. All right, addition and subtraction take some effort. Lots and lots of little things you have to be paying attention to. But that's the basic examples. You can find practice for these in your Pre-Calculus 11 textbook. Section 6.1 has simplification and the idea of non-permissible values. Try some of the harder questions in that section. You probably don't need to spend a lot of time there. Multiplication and division, again, do some of each type. Make sure you're doing the hardest questions in the section. And 6.3, addition and subtraction. That's probably where you're going to need to practice the most.